Hi, my name is Przemek Bajer, and I'm a research assistant professor at the University of Minnesota. I'm also the owner of Carp Solutions, which is a private company. And today I'll be talking about new technology and strategies in common carp management. I think Peter Sorensen will be presenting ahead of my talk, and I think Peter's covering a lot of ground on carp behavior and life history and ecology and some of the more common management techniques, so I will not be covering any of that. I do want to mention three management techniques before I get to the main point of my talk. The first one is biocontrol. Since we discovered that bluegills can play an important role in controlling common carp populations by feeding on carp eggs and larvae, I see effort from different groups to increase bluegill populations, and that could be done sometimes using aeration systems to prevent summer or winter hypoxia, to strengthen bluegill populations because bluegills are sensitive to hypoxia. That works in some lakes, however, it's not going to work in very shallow lakes or marshes. The next one is genetic technologies. I'm being asked about that quite a bit at different meetings. You might have heard about the Trojan males or YY males, which are being used for brook trout control out west. And these technologies may be effective in short-lived species such as brook trout, but they're unlikely to be effective in long-lived, highly fecund species such as the common carp, and there is actually a paper on that recently published. Another type of genetic technologies is gene drive technologies. This is not my field, so I'll just mention that there is a group working on those at the University of Minnesota, Mike Smansky's lab, and Mike would be probably the best person to reach out if you want to know the latest on the state of these technologies and when they might be available. Finally, I want to say a couple words about pathogens. Pathogens were thought to be perhaps a silver bullet for carp control in Australia. Now it looks like the Australians are moving away from that. In the US, carp pathogens such as koi herpes virus or carp edema virus are already present. They've been detected in multiple lakes in multiple states, so they're here. Again, they're not a silver bullet for carp control because what happens is we actually find presence of viruses in lakes with very abundant carp population. So likely the lakes were introduced to the virus, went through initial mortality, and then the populations gained resilience. And again, not a silver bullet. Okay, so through the rest of the talk, I want to talk about the new technologies that we developed and tested. Not silver bullets, but they're practical, they're selective and relatively affordable, and they're also automated and can be remotely controlled, which reduces the labor and cost. The first one is related to summer removal of adult and juvenile carp with baited box nets. Carp are social animals and can be trained to aggregate in lakes using bait. We started doing first experiments on that in Peter's lab in 2010, where we baited one area in a small lake and found out that in just a few days we were able to attract the majority of the entire population to that area. This is what it looks like underwater. The carp can learn quickly about the bait. It usually takes them 3 to 4 days to start forming those large aggregations. So there is a lot of carp and only carp. As you can see in this video, we're not attracting any native fish to the bait we use. We use cracked corn, just the carp. So this technique can be quite selective, species specific. Aggregations of carp can be tracked online, remotely on a website. What we do is we initially implant a sample of carp in a lake with pit tags and release them. And then we place pit antennas at the bait, so whenever tagged carp are feeding on the bait, that information is detected and sent to a website, and you can track it remotely. You're looking here at a plot showing number of unique pit tags per hour over multiple days, so you can clearly see daily feeding patterns and spikes in carp activity. So when you have that information, you know when to pull the nets, when to catch those fish remotely. This is an example of one of those baited box nets. They're typically 30 feet by 60 feet. They have mesh sides and mesh bottoms. They're surrounded by metal posts with counterweights, and each post has remotely controlled triggers that can be activated to release the weights. The weights drop down, the net goes up, and the carp are caught in the net. This is what it looks like. So now the weights dropped, the net came up, and the carp start jumping in the net. But remember, the net has mesh sides and mesh bottom, and at this point the carp cannot escape. This is how we remove the carp from those baited boxes. This is the easiest part of the removal process. What happens is we put a floating boom underneath the bottom of the net, push it forward, pushing all the carp towards one end of the net, and then we roll them onto a boat using cranes. This video is quite noisy, so I hope you can hear it. Typically have multiple nets in the lake, and a crew of 4 can work on several nets in a day. Once the fish are in the boat, you can sort the natives and release them. But as you see here, these are pretty much just carp. You rarely see fish other than carp in those nets. We tested this technology in Lake Allegan in Michigan, which is a reservoir in central Michigan, 1,600-acre reservoir. There were multiple groups working with us on that project. I'm listing them here. Before we even started carp removal, we asked the question whether this lake is a good candidate for carp removal. To do that, we did aging analysis, and even though the carp were small, they were quite old. The median age was 45, and there were no carp younger than 20. So we hypothesized that carp did not have a successful recruitment event in that system in the last 20 years. So we thought that if we start removing the adult carp, they are not likely to be quickly replaced by juveniles. There were also several species of native fish in the lake. They were not abundant, but they were present. So we hypothesized that as we start removing the carp, the abundance of native fish would perhaps increase, eventually tipping the balance in favor of the native fish. So this is the study lake again, and these are the number of nets we had in the lake. 2019, we had 7 nets. 2019 was a pilot project. 2020, we had 15 nets. 21, 19 nets. 22, 15 nets. Each time, we tagged between 300 and 1,000 carp with pit tags and released those fish to allow for mark and recapture analysis. In this table, you see data for each year, number of nets, number of net pools, number of carp tagged, number of carp recaptured, removed, percentage of tags removed or recaptured. I want to highlight a couple things here. Number of net pools. During the 3 heavy-duty years, 20, 21, and 22, we're doing between 100 and 300 net pools. So even though we have multiple nets in the lake, for example, in 2021 we had 26 nets, each one of those nets was pulled more than 10 times. So the way this works is you install the nets in late May, they stay in the lake until October, and you can come back to them every week to 10 days to repeat the training and removal process. Another column I want to highlight is the percent of tags removed. So we were removing between 20 and 50% of the tags, which is 20 to 50% of the population each season. Overall, over 135,000 carp removed. We fished the biomass down from about 450 kilograms per hectare to just under 100, which was our management goal. We did see young of the year carp, but only during 1 year in 2021 in low numbers. We don't think they came from Lake Allegan. We think they came from another reservoir upstream, Morrow Lake, which had a dam issue and was drained in the fall and then filled back up in the spring, which created about the optimum carp nursery. That resulted in carp pulling off a huge young of the year class in that lake. And we think that the young of the year carp we caught in Lake Allegan actually came from Morrow Lake upstream. And that was the only time when we were seeing any young of the year carp in the lake. So again, removal appears to be sustainable. The bycatch was minimal, only 3%, primarily channel catfish and flathead catfish, which could be released alive. again using cracked corn as bait. We were seeing some changes in native fish community. So we're looking at small mesh trap net catches in 2019, which is prior to management, versus 2022, which is after the bulk of management occurred. 2019, and this is logarithmic scale, the catch per net was about 30. 2022 increased to over 1,000. And in 22, we're seeing a lot of young of the year smallmouth and largemouth bass. So clearly some potentially positive effect on recruitment of bass. It's too early to say if those fish will survive to adulthood. I think the next fish survey is planned for this year. We're also seeing some changes in yellow perch population, and those are adult fish. These are gillnet catches. 2019, which are the black bars, 13 perch were captured in gillnets. 2022, over 400 were captured, so big increase. And these are the lengths of those fish. So those are not young of the year. Those are adult fish. So it looks like some positive changes are happening in the lake. The next technology I want to talk about is using low voltage deterrence and guidance systems for removing carp during spawning migrations. So the first one, the baited box nets, those are used in the summer when the carp are feeding. This one is used in the spring when they're migrating from lakes to marshes to spawn. This was our study lake, our study system really. I'm not sure if you can see it, but this is Long Lake in the lower left. And this is Rice Creek flowing into Long Lake. And Peter Sorensen and Nate Benet did an interesting study in this system where they tracked the movement of adult carp using radio tags. So these are radio tagged common carp highlighted as those black dots in Long Lake in March, early March. And these are the same fish in late May. So clearly a large upstream migration of the adult carp from Long Lake to those nursery lakes to spawn. So what we did was right upstream of Long Lake, we've installed our low voltage guidance and deterrent system to block those migrating carp and remove them. This is our study site. Hopefully you can see the 2 rows of electrodes going across the stream, and these are used to block the carp and direct them into a trap. This is another view of the electrodes. Positive and negative row producing mild electric field intended to guide the carp into a trap. This is the view of our trap. So the fish are guided into this fairly large enclosure. Well, it was 15 feet wide and 80 feet long. And once the carp were inside the enclosure was closed. And inside we had additional arrays of electrodes that were used to aggregate the carp and push them on top of conveyors for removal. This is a photo of the carp aggregation process. So we're pushing the carp from the left-hand side to the right-hand side by turning on the electrodes, rows of electrodes one by one. And eventually the carp were aggregated tightly on top of the conveyors and removed. So again, no labor in the water, no need to wade around and catch the fish with nets. This can be all automated. We tested the efficiency of that system during 2 entire spawning runs, 2021 and 2022. We used pit antennas upstream and downstream of the barrier. We had over 1,000 pit tagged carp in the system to track the migration and removal efficiency. In 2021, we removed 56% of the spawning run. In 2022, we removed 68% of the spawning run. And each year we had about 20 removal days. Overall, 24,000 carp were removed during the spawning runs. 92% of the carp were blocked from going upstream, so 8% did go through the electric barrier. We don't think they actually went through the barrier, we think they went around it because they were able to scour an undercut along one of the banks and probably moved upstream through that. The bycatch was released. We also used additional removal of baited box nets in Long Lake. And using those, we removed about 7,500 carp. So in that system, we had both of those technologies combined. Low voltage systems during the spring run and baited box nets in the summer. And we have a paper coming out on that hopefully soon. We fished down the population from about 35,000 carp to just over 2,000 carp, and the biomass from 670 kilograms per hectare to 70 kilograms per hectare. So again, we are below the management threshold, which is great. And we didn't see evidence of any recruitment in Long Lake. Again, suggesting that this effort should be sustainable. All right, with that, I'll be happy to answer any questions you might have. And also, if you'd like to see more information on those technologies, you can go to our website and also see our YouTube channel. Thanks a lot.